Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Okay, so these can be fairly difficult Lewis structures to get. So for this N2O5, we have essentially this as our core structure, and then there's going to be two oxygens coming off of each nitrogen, like this. And we still have some extra electrons if we count them all up, but we can also tell this by the fact that if oxygen only has one bond, that has a negative charge, which means that this would be like a 4- species. So we've got to put in extra electrons. Like this, we see that our nitrogen has one too many bonds, giving it a plus charge, or oxygen has one too few, giving it a minus charge, and that'll essentially cancel out. So this is our neutral molecule. We can kind of decorate the outside with lone electrons to show that more exactly. One electron pairs, rather. And now we need to know how many hybrid orbitals we use to describe each molecule. So the hybrid orbitals are just going to be our sigma orbitals, which is going to be 1, 2, 3, 4, 5, 6. And the reason we're not counting the pi orbitals is those aren't hybrid. They're just p orbitals. These are going to be 6 orbitals, or 6 overlaps. I guess each molecule has 2 orbitals. So it would be 12 total hybrid orbitals. For this next one, one hint that we're given is that we have 4 carbon-hydrogen bonds and 1 OH bond. The reason we need that is there's multiple different ways to arrange this. So what that tells me, though, is that this nitrogen doesn't have any bonds to hydrogen. So I'm going to start out by drawing a carbon with 3 bonds to nitrogen, which is essentially a way to guarantee that the nitrogen doesn't have any bonds to hydrogen. And now I have a second carbon with an OH. We're given that has an OH. And if we draw in 2 bonds here, we see that we haven't quite hit our target. We're 2 hydrogens short. So we need to add in 2 more bonds to carbon. And the way we're going to do that is by putting this nitrogen in the middle here. So erase this. We put our nitrogen in the middle. We can then put 2 bonds to a carbon, so nitrogen has 3. And now we can put in our 2 more bonds to hydrogen. So that's what our structure is going to look like. We can add in the lone electron pairs here and here. And again, if we want to know how many hybrid orbitals, we can count up all the bonds that aren't p bonds and multiply by 2. 1, 2, 3, 4, 5, 6, 7, 8. Except hydrogen bonds or hydrogen atoms don't form hybrid orbitals. So these are 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 11 hybrid orbitals would describe this molecule. And finally, we have one of the easier ones. We can sort of recognize this CN as a carbon with a triple bond to nitrogen. It's called a cyanide group. And then carbon needs 1 more bond. Bromine likes to form 1 bond, which is why this one's not particularly challenging, part C. We do that. And again, we form 2 p orbitals here. Those aren't hybrid orbitals, so just 4 total hybrid orbitals would describe this molecule.